Hey, my name is Jameel Nabbo, and I was recently like doing exploit development, working with the government, pen testing military devices, and so on. So I was focusing on like static code analysis and finding vulnerabilities within these devices, mainly debugging and stuff. In this talk, I'm gonna present two techniques. The first one is about like reverse engineering with the one Kung Fu liner for a vulnerability scanner, which is I took it like as an example, not targeting these company or something, but I took it as an example to show how easy it is to just jump over and change the application logic and execution flow. And this can be applied to antiviruses, IDS systems, and whatever. Same technique. It's pretty simple. The second one is about like Java, some sort of 0-day in within Java. It has two options. The first one is pretty much easy to exploit, and the second one, we need to dive into the cryptography in order to inject our payload. So I'm gonna begin. It's all hands-on, so hopefully it works. About activating a program or a software, so the application, of course, like should run, and then after running, whatever the complexity of running this application gonna depends on an activation key, mobile phone, downloading dependency, or like a USB or whatever. So the logic here is there's F then, but it's some places, and what makes it like complex, it's when to detect and how to detect these spots in order to activate something, you know. And then after that, like modern application makes API call or like with the web services. And then if it's get validated, so the application activated, if not, so in same circle. So in the regular reverse engineering techniques, there's these kind, you know, of checklist, like playing around with the timing, isolating the environment with a sandbox or something. So isolating the application from detecting the remote server time, or playing around with burp, or playing around with fiddler, intercepting the request, and so on. So this is the regular cracking stuff. We're gonna do the jump. It's pretty simple. It doesn't require that much into diving into the application or understanding where is the EIP and how it's overwritten, and then how we can jump over or like buffer overflow techniques, deeps and SEH. It's much more simple than that. Basically, it's we're gonna not even fuzz the application. We're gonna just run the application, understand how the workflow is going on, and then from then, like, we're gonna see the ASCII, where is the activation happening, and from that spot we're gonna jump over to change the application logic and get it activated. And the regular applications and even the modern one, what they do actually, when you activate something, it writes some values. Let's talk about Windows. It writes some values to the let's say the files, temporary files on temp directory or in the registry or so on, and then it checks them every time you open up that application if these values are set, so everything is cool. So basically, if the activation field is in memory address, like as an example, so we put a breakpoint before it, and then we jump to the activation part, and that's it. So, but we're gonna see it in action right now. So I choose a popular real-world application, like, you know, a vulnerability scanner. That was researching as well for really big, you know, antiviruses and etc. All of them works in the same technique. So it's a brand new installation. So just doing it for research purposes, not like for anything else. All right, cool. So this is the product. It's, I think it's a trial. We need to activate it. Quick research, there's, activation part. In other application, it may be embedded within the application file or whatever, I'm gonna use like pure OLA debugger without any dependencies or Mona stuff. And just run out the application, clearing some values. Okay. So we got the application, the activation part is running, so I'm gonna just attach the process. Let's find it. Okay, it's here. Loading the library now, it's phrased in the memory. Regular cracking, how it goes is actually like fuzzing the application, understanding where's the instructions, where's the ASCII stuff, and how the modules are loaded, and going into IDEA Pro and discovering the function and stuff. This, like, it's powerful, but it's a time-consuming process. There's another easy process to do that. So simply, I'm gonna just like jump into the modules. There's a bunch of modules. You can like say classes. It's a C++ application. So the one here is the activation module. I just jumped over. And then to prevent just like reading the line by line, the assembly instruction, I'm just gonna go search for or reference text string, which is gonna bring me to a new window with the ASCII stuff, at least readable. Searching about activation part in the entire scope, clicking OK. So I'm gonna just like Control L, search for next until I find something interesting. Okay, let's just check this out. I don't know if it's visible. Activation result, activation failed. Activation result, activation was successful. All right, let's just dive into it by double clicking it to see what it does. Basically push some stuff into the stack if the key, for example, not found, and I need to be connected to the internet. So I can really understand without diving into the executable or the binding file that it makes an API call. If something went okay, then continue. If not, so jump over here and then it's not activated. So we are talking about a security software. We're not talking about like crackme.exe or something. What I'm gonna do is I'm gonna put like a breakpoint over here, toggle a breakpoint. All right, I'm gonna make a play around. Just scroll along the way to get the address of the activation. Jumping over, just right here, I'm gonna like assemble this place where it say G, which is jump, paste the address, delete the rest. Okay, cool. Assemble. That's it. So it's a pretty simple technique. Like when it comes over here, you're gonna see this address and it would jump on. We need to run the application. So it's in, come on. Yeah. Whatever. When I click next right now, if we check the EIP, we came into our spot. So what I'm gonna do is like just step over. We came over here and our, like, the point that the address that we changed. So if everything goes well, I should jump into the address that is specified, which is the activation successful. Hitting and continue button. That's it. Activation was successful. It's pretty simple technique, whatever the complexity of any application. So it's on the same logic for hours. And you can use it. Preventing the jump technique over application takes a really lot of work. Even if the application, doing a security job. So when we talk about a company that does a security job, so these guys really understand how secure coding made up and how to write a secure code. But like making your application not reversible, it's really hard. But there's, some, this is for fun. Like I always see it on LinkedIn promoting if the website is secure or not. If you want to prevent it, so basically separate the logic of the checks, and every time that you go to make a process to validate something, just separate the logic. Don't put it in let's say one DLL or one function and calling this function, and even talking in depth into programming. If you have a class from static, like a static class, and you have a helper, let's say, and the function that does the check, or a void that does the check, procedure, method call, or whatever, and you call this function in multiple places. This makes it, like, for the attackers or crackers, pretty easy to bypass. So this is the first part. The second one is about exploiting the view state serialization. It's really common, like the Java serialization part, when you have, let's say, a JSON that is loading from a different area, and then you deserialize this into object, and then you do whatever you want with these objects. But this goal is not about like serialization. We are talking about the environment itself. The Java GSF itself. So I got an application with the best security practices enabled, everything encryption, and from the server side, and all of this is enabled. So the best practices enabled. Before that, let's talk about how GSF work, and in short description about how it works. If you are using, for example, Apache MyFaces or other, GSF, who does the implementation for GSF, they basically have a view state, and this view state sometimes, like, it's encrypted, or depends on the configuration if it's encrypted or not. If it's not encrypted, so yeah, we have a problem. If it's encrypted, we need to take the secret key. This was a really cool challenge that that crazy company that I applied for, they gave it to me, and then I found, all right, I need to find a 0-day or something. And when you really search about these things, you're gonna find similar, but not the exact exploit. Where there's no exploit published for how to, you're gonna find articles, there's something exists, but you won't find how to exploit it or something. So it took me a bit of research to understand the encryption part and how to generate it. How the exploitation works, actually, we're gonna dive into we're gonna take it into the hard way, which is we're gonna have like a view state that is really encrypted, and we have a secret key and everything, but we assume we have the secret key, but we're gonna inject our customized payload into the shell code. So we have to make a shell code and then inject our payload within the shell code, because here you have two stages of the shell code. The first shell code, which is gonna invoke a gadget in the environment itself, and the second shell code is your execution command in order, like, for example, to get a reverse shell on something. But the problem is with injecting a shell code, once we say a view state is really encrypted, so you have to make a play around on the server that you have generated this view state, and yeah, this is the one that you generated, and then I will execute my command on the server side. So basically we just need to find the view state, and then the secret key, and generate that payload. If you search about MyFaces view state, you're gonna end up with this article, and none of them write any exploit for it. And what they say over here, even a gadget that is not yet known to the public. So this is the one that is not known to the public yet. So there's other gadget like Invoker and stuff, but this one is not, it's not public. Here, what we're gonna do, I already have the exploit written, so we're gonna build the payload. This part already passed, and we're gonna inject our reverse shell within the payload. So we're gonna have multi-payload and our command within the payload itself, and then we're gonna encrypt the payload using DES, which is the default one that MyFaces uses, and also you can use another one, and also you can edit it with the exploit and gonna work. So there's no really solution for it for MyFaces. And then we're gonna calculate the hash message authentication code, the HMAC, as it's generated in the environment, and then we're gonna encode the final, cipher that we get into a base 64, and then we're gonna send it to the server, and hopefully waiting for reverse shell. So we're gonna see it in action. By the way, this is working on the latest version. I deployed it on the latest version of Tomcat. All right. So this is the application. There's no tricks in terms of any serialization that have been made. We are exploiting the environment itself. So we basically have a user form, which is it's taking the username, and then it says to the user, let's open them up in separate files. Okay, cool. So basically we have two GSP files. It takes the username that you passed in, and then it's printed out. No tricks, nothing. And we assume over here we have the configuration for the deployed application. So this is the secret key, and this is the HMAC, which uses SHA-1. And over here we have it. So let me just search for. Okay. So it's generated from the server, so it's not from the client side. And over here I have Tomcat. It's up and running. I'm gonna deploy the file. Now it's deployed. This is it. Looking at the source code. We have these IDs, which is, the GSF uses hidden fields, and then it uses the view state, and the view state, which saves the current view state, is all encrypted. All right. No access, SS, nothing, injection, nothing. So basically, if I type something, let's say hello. Looking at the exploit. I'm using request, base 64, crypto stuff, the host that gonna communicate the port, checking the user argument. Okay. And here I'm checking if the view state is found on the URL that you supplied or not. And here's the payload. Start from here into multiple parts. And here it inject the command. So this is a function. It inject the command, and then I can call this function and pass this command to it. And then it will be over here. So the whole payload, I'm gonna re-encrypt it to DES, and then get the base 64 out of it. And how do I know how the encryption mechanism working? Is just by visiting the documentation. Here's the exploit. We are providing the secret key, base 64, and then we are encrypting using the ECB mode, which is, it works in parallelism, which is much faster. And then we are passing this to a variable called encrypt, which encrypt our payload. And then right after that, we are calculating the hash method authentication code for this payload. We combine them together, and then we encode them into base 64, and then right after that, we send them to the server. Let's see how it works. What I need to do is simply I'm going to set up a listener. Running. It's a brand the view state that for debugging purposes, and then we got the reverse shell. Of course, I'm running it as root, so it's running as root. This kind of exploitation technique by using my faces, there's tons of thousands of websites that is implementing GSF using my faces, but over here we are assuming that we have the secret key, which we generated the HMAC. There's other exploitation techniques which doesn't dive into the encryption stuff, like only the cipher itself and then executing. What are the advices to prevent these shits? Personally, I don't prefer to implement the GSF using my faces, so it can be done with other things, But of course, over here, in order to run this exploit, you need to have the secret key. So if you don't have the secret key, you need to brute force and do stuff. So yeah, these are the advices, like use it from the server side, which already exists in my faces, and enable the encryption of your view state. This is basically the stuff that I wanted to show.
Thank you, Jameel.